let me tell you what we're going to be talking about next. Emerging Trends and Innovations is the title of our next session. And we have 3 speakers coming up to join us, and then we'll start a panel discussion right after that, and that will be the close of the forum for this year. And welcome back also to our online viewers. Thank you very much for continuing to watch the live stream. Don't forget that poll, the results of the poll will be coming up right at the end. So why don't we start by welcoming to the stage our next guest. We've got Prashant, we've got Emma, and we've got Ben. So please, coming up to the stage, and we'll start our first session. Round of applause. Prashant Agarwal is the VRAN Business Development Manager for Intel. So Prashant, I will leave it to you to start your presentation. Over to you.
Hi, good morning, everyone. It's great to see such a good turnout on day 2 of conference. If you are here for insight, or just for connections, or just for coffee, I'm glad you decided to stay. I'm Prashant Agarwal, Business Development Manager for Telco from Intel, and I'm excited to be part of this session. Let's see. Before we get into the details, let's spend some time to see how the AI workloads are evolving. As the AI moving forward, so different tasks are emerging, and it's making it more likely to choose your hardware wisely. You can also see it as a timeline. We started long time back, like 15, 20 years back, with the machine learning. Then we moved to deep learning, and now you can see the new generative AI, which is like a next format of the deep learning itself. And now you can see CPU is good, and it's perfect for like earlier models like machine learning and up to some extent deep learning also. Maybe not that perfect for the large models like ChatGPT for generative AI. But again, all the models are not same. They have different requirements. So by learning all these different models, we can finally decide what hardware can be matched to which AI workload. In summary, that's the main thing. So how can we make sure that we use the correct hardware for the correct AI workload? When we talk about the AI, GPUs are like a default choice. Everybody talks about the GPUs for AI workloads. And they are great. They are great for some workload, but not for all. All AI workloads are not same, and that's why they don't need the same hardware requirements. For example, let's spend some time to look about this. So we have here in the blue sides, we have Intel Xeon CPUs, and on the green one, you can see the GPU sides. So let's start from the CPU sides. They are great for running like a classic machine learning model, like inferencing, tuning, and training. They are also good for deep learning inferences, where you have less than 20 billion parameters, and also for tuning and learning also. Regarding deep learning training, less than 10 billion parameters and up to 500 GP training data, they work really well. And also for RAG also, especially if you are dealing with the private data, they are perfect. And now let's think about the next one, about the GPUs. They are built for the heavy workload, as we all know. For example, if you have deep learning inferences, more than 20 billion parameters, and let's say less than 100 millisecond latency requirements, they are perfect. Similarly, about the training, if a model is like more than 10 billion parameters, more than, let's say, 1 TB data, GPUs are perfect for that. And for RAG also, if you are dealing with the public models, they are perfect there also. So in summary, the point here is not all AI workloads are same. So you need to really understand what workloads you have and what's the perfect hardware to run on that. So that's the key, to match the right AI workloads with the right hardware. And there is another message. There is a message for like network operators also here. See, most of you already have a big network infrastructure. You have a lot of servers running on CPUs. And they are perfect to run most of your AI workloads. We know that, as you can see, the GPUs are required for the high AI workloads. But for telco side, I mean, telco workloads and the RAN workloads, I think most of the time you will find CPUs are more than enough. So you don't really need to wait for any additional hardware. You can start deploying these AI workloads, especially in telco side, on your existing hardware. That will just speed up all your process. You can learn many things, and you are ready for experiments, and then you're ready for scaling when the new workloads come. Okay. Let me move to the next one. So as we see that AI is evolving very fast. So from classic machine learning, and then we see the genetic AI is coming. So it's evolving very fast. And now we all know that's like LLMs deployed in data centers. GPUs are great for them. There's very large language models deployed in data centers. But the main demand is coming on the edge and devices, where the models are much smaller, and the requirements for processing power is less smaller. The key things for the edge and devices are power efficiency and the cost. And that's where Intel CPU with our accelerators SoC that shines there. It's built to deliver the performance, but same time check the power efficiency and the cost. And that's the perfect for the edge and devices. And now you can see in this picture, starting from the left side, you have the data centers. Again, on the data center, I mentioned the LLMs are being developed there, and they are the critical part of network automation. And now you see in the middle part, which is like a core network and RAN infrastructure. And there we see this generative and agentic AI are being implemented to provide the high spectral efficiencies and energy efficiencies. But then you move towards the right side. That's where we call the edge network infrastructure and devices. As you can see, this is where now we have 5G and 6G. We are getting an era of super connectivity and with the high computing power. What it's doing, it's allowing the AI to come out from the data centers in the real physical world to enable the mobility application like robotics, autonomous systems, and intelligent edge devices. And that's the trend we are seeing. So in the end, as we move ahead, we think AI is just not a phenomenon. It's like a transformation. And I will again say, there's the opportunity for the network operators is now, just right now. You don't need to wait for anything. By using the existing hardware, which you already have, and by matching the AI workloads with the correct hardware, you can start unlocking the value of AI. Whether it's to improve your customer experience, or for network optimization, or for operational efficiency, I will say AI is here now to deliver. Thank you very much for having me here, and I'm looking forward for the great conversation.
Thanks, Prashant. Take a seat, please. Thank you very much indeed. Right. Great. Thank you for that. We must have a question from our audience in the room here for Prashant. Tony, do you see any signs? I see Tony at the back. Tony has a microphone, and he's willing to use it. Who would like to relieve Tony of the microphone? Whilst you're all thinking, I'm going to push a question to you based on that, Prashant. You showed that slide there of the separation between the CPU and GPU use cases, effectively. And you had the kind of subjective barrier separator between the two. As we move forward, we're talking about trends and innovations. As we move forward, is that barrier going to move around? Is that dividing line going to move?
Yeah, to be honest, what you are seeing that with the agentic AI coming, now you can see there's a smaller language models are coming, and the domain-specific models also. So what you may start seeing, the GPUs, maybe less powerful GPUs, which are fit for these sort of models. So you're absolutely right, those BS may change. But ultimately, the point is that you need to really understand and decide that one size does not fit for all. So what AI workloads you want to run, and then decide what sort of hardware you need. Do you need this? Because as I mentioned with the Intel 6 Xeon also, we have inbuilt accelerator. That's another thing. So in each core, we have the inbuilt accelerators, which are more than enough to run those smaller models and to provide in telco and RAN side. But of course, going back to your points, there will be these things will keep on moving. You will see the GPUs, which are specific only for this inference models, for example. They are not that powerful GPUs, but they are perfect for those things. So yes.
Great, thanks, Prashant. Do we have any takers, Tony, or are we going to move on? Oh, we have a taker. Thank you very much. We have a winner in the third row.
Thank you very much for the presentation. It's clear and insightful. If we look to operator landscape, almost every operator have a network cloud in order to run CNFs and telco workloads today. How do you see this platform will evolve in order to run inference for whatever software, network function itself, domain orchestrations, or cross-domain orchestrations?
Okay. That's a really good question. So in terms of RAN, if you see, there is a trend is going on, it's like towards virtualization and disaggregated RAN. So now the things are moving from the traditional RAN toward this disaggregated RAN, or we call it virtual RAN or open RAN, where you are disaggregating hardware and software. And there, when you deploy that, you have the hardware, which is capable of running the RAN workload, but same time, this is also capable of running the AI workloads. So I think, going back to your point, so when we have moving toward a disaggregation side with virtualization, that will help operators to use the same hardware to do the RAN AI workloads, and by using the orchestration and those things to control the different type of servers which they have in their network.
Thank you very much, Prashant, for that answer. Great question. Thank you very much. Right, we will, in that case, we will move on. So a round of applause for Prashant, and we'll move on to our next speakers. Thank you very much. Okay, so we're going to focus now on the role of, or more focus on the role of AI-driven automation. And here to explain more are Ben Hickey, Director of Product Portfolio Management and M&A Software Networking at IBM, and Emma Buckland, who is Research Director at STL Partners. Ben and Emma, welcome. Thank you very much for joining us. We're not going to present here. We're just going to have a little chat. I'm going to allow the two of you to chat this through. It's an area we've touched on a few times in these 2 days of the forum. But Ben, I wonder, first of all, if perhaps you could start with introducing this automation journey and how IBM got to its kind of like AI catalyst moment.
Yeah, I think that's good, Guy, to put it in that context, because in reality, we have been trying to automate for quite a long time now. Like, we're talking 10, 15 years plus, right? And I think if you look at many organizations, when with their networking teams, they've kind of seemed to have hit a cap, they've hit a ceiling. And what we've come to realize is that that actually is driven by a trust issue. So people have issues trusting their data, they have issues trusting their systems and the signal they get from their systems, and they have issues trusting their rules-based automation. So these issues are what are holding them kind of back. But as you mentioned, the catalyst, which is what makes it all very exciting right now, is this Gen AI coming along, and in particular, foundation models coming along. And so I think with this technology, we're actually seeing an opportunity now to move beyond those trust issues.
Great, thanks so much for introducing this Ben. Emma, I'd like to bring you in because I know STL Partners has done a lot of work in this field. Can you kind of give us some context and background to what you've been doing, and then we'll move on to some specifics here.
Sure, thank you, and thank you very much for having me. So, as you said, let me give a little bit of context as to the research that I'm going to describe in a second. So I think it was here on this panel yesterday, you asked, or somebody actually in the audience asked, okay, there are lots of use cases for AI and automation, where do we start? And interestingly, on the panel, they all gave a different answer to that question. So what our research really is, or has been trying to do, is to actually look at all the use cases that the telco has in operating its network and OSS. So we have listed 44 processes, actually. and think, okay, what can intelligence and what can automation improve in those processes? So obviously, what money can it save us, but also what is it that we're going to do better, and therefore what new revenue might we be generating? So it's a model in Excel, essentially, that we have developed and we have been running in for a number of years. It's something we do in collaboration with a friend of ours called Charlotte Patrick. And we're looking at an average telco. So the average telco has $16 billion of revenue. It's a fixed and mobile operator. I'm not going to bore you with the detail, but let's call it the average telco. And for the average telco, bringing more intelligence and more automation in the network and OSS will bring financial value. So I'm not saving money. I'll explain again why. That is equivalent to 5% of the top line. So if you make the math very quickly, 5% of 16 billion is $800 million per year. 5% might not seem like a large percentage, but actually, if you look at most telcos and their connectivity business, it's not a part of their business which is growing particularly. So any money saved, any new money to be made is good to have. So if I look really at what comes within this 5% of financial benefit, there are obviously bits that are savings, and there are bits that are going to be new revenue. So by and large, the savings come savings from OPEX, and that's actually half of that 5%. There's going to be savings from CAPEX, so less money to be spent on network elements because we use what we have in the network more efficiently. That's about a quarter of the 5%, slightly less actually. And the rest is generating new revenue. And I want to double-click a little bit on what we mean with generating new revenue. We are not talking about super fancy services here, or things that telco might be doing more of in the future. Yes, we think, by the way, at STL Partners, that telcos should definitely look into those services, but we're looking at doing connectivity better here. So having a network which has better quality of service, so your customers are not going to churn, and obviously each customer is associated with an ARPU. If that customer doesn't churn, you multiply it by your ARPU, that's your new revenue. It also means that when somebody wants to have service from you, you're able to provision that service more quickly. That's going to have a good ricochet effect on your NPS, as, by the way, is the better retention. That's going to attract more customers to your network. So that's the three areas where we see the value coming. There's a bit coming from OPEX savings, a bit coming from CAPEX savings, and a bit, not a huge bit, but still an interesting bit coming from new revenue generation.
Great, thanks. So, do you want to continue? We saying something else? I think I just interrupted you by mistake there.
No, you haven't.
Correct.
I'm sure I would perhaps speak on what Ben is saying to give a few more figures, but let's not drown the audience in figures quite yet.
Well, it's some fascinating figures there, and the 5% figures is fascinating, and maybe we'll get some questions from the audience to pick up on that one. But just what's the relationship between you and the research here with IBM and STL?
Yeah, so I think STL has shown to have this research and to be able to model out these benefits. And so we wanted to work with STL to talk about some of these new technologies that we are bringing to market and that we're seeing can really impact it. Because when it's new, that's one of the challenges people have is, and you see this question coming up again and again with AI right now about what is the ROI. So by being able to work with Emma and the team at STL, we were able to share how we can impact that with the AI technologies and then have STL be able to map that to the benefits that could come out.
Well, let me just throw a question back to you about this research, if I can. In the course of doing this and evaluating it all, any surprises, any standout surprises that went against your expectations, maybe, or are we tracking pretty much as you predict?
Well, I think. Well, let me perhaps turn the question on its head. What are the things that the research has sort of validated? Obviously, a lot of the money to be made is going to be where operators actually spend already a lot. So there's a lot of savings to be made in managing the RAN better or planning the RAN better, using the energy more efficiently. So these are really the very big items that can be saved upon. And then I don't really want to steal Ben's fire here, but there's also money to be made in better managing the network.
Right. Well, we'll come on to that, shall we? Ben, let's look into that, and also, general trends that you're seeing independently and through this research that are impacting the whole network lifecycle.
Yeah, I think one of the things we wanted to try and test with this research was, we've all heard this idea that AI is coming for your jobs, and what is that going to mean in the telecom space and for our engineering teams? Because we're also quite aware, many telecoms operators have really made significant headcount reductions over the last few years, and many of them, if you like, are running skeletal teams. So the worry was, well, if we get this benefits from AI, but it has to be derived by reducing headcount, but we're already at the skeletal stuff, the minimum amount of headcount we need to run the network, then whatever benefit, 10, 20, 40, 60%, if you multiply it by 0, it's still 0. So what Emma's research showed was really the benefits outside of just people, outside of OpEx, and showing that there are benefits to the CapEx and the revenues as well. So that was a huge success, being able to see that. But going into the example that Emma mentioned, I think, and it comes to this question of where do you start? 78% of the benefits actually came in day 2 operations. And so that's kind of as you'd expect. We know that space very well. And so when you look into it, this network management area, there was actually a quarter of the benefits came from better managing the network. And that kind of proves out what we're seeing with the foundation models, because in many ways we can now completely revolutionize how we handle the data that our networks produce, and we're going to be able to move from a reactive mode of operations to a proactive mode of operations. And so we can start to use the AI for the first time to analyze data as it comes in, to identify issues with a much higher degree of accuracy, but also to find the kinds of issues that people normally have to wait for their users to complain about. The ones that slip through the net of current systems. So this kind of proved that out, and it showed that there was a huge value to go and target that initially.
Excellent. Thanks very much, Ben. I'm going to pause now because I'd love to get the audience in and get some feedback from some of the audience members, because I'm sure there's going to be a question. Tony's on microphone duty, and I know we have one at the front here. Tony, I'm sorry, I'm going to make you run all the way down to the front. It's coming, Francis.
He does this on purpose.
He does. Yeah.
Really great conversation. I'm slightly intrigued. In terms of the ROI you've identified, I think the industry has really been talking about OpEx savings, CapEx savings, quality of service improvements, and value-added services, I think, as long as I've been doing ROIs for various vendors. What are you seeing as the distinct differences that AI make to this beyond the sort of typical, we've always needed automation in the network, we've always needed operational system? I'm just intrigued as to what, particularly you, Emma, what were you seeing as what's different about AI in terms of this area? Thanks.
So first, if I may be anal, we haven't calculated an ROI, so what we're looking at is what financial value will intelligence and automation bring, but we're not taking into account what operators actually have to invest for that to be the case. And we're looking at the whole spectrum of intelligence, so we are actually taking into account methods such as rule-based automation, predictive AI, generative AI, agentic AI. So I think the new techniques, and perhaps Ben can speak to that perhaps a bit more eloquently than I can, are bringing some of these benefits closer to the reality. But there's another point I wanted to make, actually, which perhaps I forgot to make when I was discussing the model initially. The benefits I'm talking about are going to really be able to be realized if operators adapt their existing workflows and change their workflows so that they can get the full benefit of AI. So there are practical implications of that. We were having our STL event this week, and one of the analysts brought a really interesting anecdotes of iPads that had been distributed to the field force of a telecom operator for them to get the copilot on the screen and be able to do the repair when they were at site more easily and so on. And for some reason, they found that actually the iPads always got broken, because what happened is that the iPads was stuck at the bottom of the bag, all the tools on top, and obviously the iPad was broken all the time. I would imagine in this case the benefit of AI would be 0, because actually you can't really operate it. So I'm not sure if I have answered your question entirely, Francis, but I've certainly given you some anecdote here. Ben, I don't know if you want to add anything.
Maybe the two things, and we can obviously talk a lot more about this, but what we see is the shift from traditional machine learning algorithms being very task-specific has been the kind of root cause behind our systems producing a pretty poor quality signal-to-noise ratio, if I put it that way. So now these foundation models are coming along, and in particular, we can recognize that agentic AI and LLMs are absolutely going to deliver a lot of value, but they need to be complemented because they don't understand this time series data. And we have this new type of foundation model called time series foundation models. So for the first time, we have a general purpose model, if you like. We don't have to have all of these discrete machine learning algorithms that can handle the various different types of data coming out of the network. So that's what I meant about moving from reactive to proactive. You know, the proxies, the things that network operations teams use today, they use things like alerts and thresholds. So you have to wait for that threshold to be breached to know there's an issue to then work backwards. Well, what if you could actually see the degradation before the threshold is hit, and then you start to pick that up much easier, let alone just finding a lot more things that you wouldn't find, because every threshold, every alert you set comes with a cost, because it can be too noisy. So that's really on the analytical AI side as we see it. And then if you come back to the reasoning, the agents, just the value they will bring moving beyond rules-based automation is going to be huge. So these two things together, I think, is the big unlock.
Great. Thanks, Ben. Thanks, Emma. We've probably got time for one more question. Any of our guests, actually? We've got a question for any of our guests. If anyone want to... Yes, we have one here. Thank you very much, Tony.
I have a question. I think it's very interesting to talk about how some operators are only operating in skeleton mode for the number of FTEs, and that we need to upscale there. So maybe question to Emma, in your digital twin of the average operator, how many FTEs are in your OPEX savings of the 50%, or what is the percentage of people you could remove? Because this is, I think, the big elephant in the room, and second day we never talk about. So can you comment on this?
So I can't give you the exact number of FTE that is in my model, but I could probably find out. But I thought you had given the number, Ben, in terms of, so on the OPEX savings that we are modeling, there's 70% of it which comes from non-human reduction. So it's improvement, obviously, a lot of it is improvement in the use of energy for a mobile network. You know, obviously that's a big bucket. And it's improvement to processes in general. You're also going to have, if you remember, there's a little bit of CapEx savings as well. Well, actually, not a little bit, that's a quarter of the overall 5%. So obviously, by having less equipment in the network, you're going to have fewer licenses to pay and so on. So it's not all, I just want to emphasize that it's not all at all about human reduction. A large percentage is not about that.
Mm-hmm. Great. Thanks so much, Emma. Great question. Thank you very much for asking that. Just a quick one from Dean before we move on to our panel.
Benefits of physical AI automation, such as robots doing fiber splicing or use of, well, actually robotics in general in the telco domain. I saw one which was a mobile base station where they actually moved the antennas in and out physically.
Sorry, is that a question or a statement?
That's Dean's statement. There's a question. Are you seeing benefits like that?
Yeah, obviously. Yeah, they are, yeah. Yeah, and that's taken into account to some extent in the model as well.
Okay, well, we hope to see more examples like that when we reconvene in 12 months' time, because I really do expect we will see more. We must end this session now, though, because we've got our final panel coming up. So please, I'd like to thank Ben and Emma, first of all. Round of applause. And